The lesson topic for this video is simplifying rational expressions. So what is a rational expression? Well, a rational expression is an expression that has a ratio in it. It has a ratio in it. It's the ratio of two polynomial expressions. Remember that polynomials can be just a number, just a variable, a combination of a number and a variable, or even the addition or subtraction of different terms. So these are all polynomials. So a ratio of pretty much anything we've been working on that is a polynomial. So is this a ratio right here of two polynomials? Sure. And it's just a fraction. And we're used to simplifying fractions, but I want to remind you way back when you learned how to simplify fractions, probably in elementary school, this is the process you used. You had to think of the factors of 4. The factors of 4 are 2 times 2. And you had to think of the factors of 6, which is 2 times 3. Then we had to think about whether there were any common factors in the numerator and the denominator. And there is. The number 2 shows up in both, and so the 2 in the numerator and the 2 in the denominator you can think of as 2 over 2, which is 2 divided by 2, and 2 divided by 2 is 1. So then we end up getting 2 times 1 in the numerator and 3 times 1 in the denominator, and our fraction of 4/6 simplifies into the fraction 2/3. Now, 4x over x, the same kind of thing happens. It's already factored. We could break down 4 into 2 times 2, but there's no need since we don't have any numerical factor in the denominator. But we do see a variable part in the numerator and in the denominator that is the same factor. So I can cancel that factor of x with this factor of x, which again, we use that word cancel sometimes when maybe we shouldn't, but x over x is 1 over 1, or just 1, which means we have 4 over 1, which is just 4. So remember, the factors that we are going to cancel out, again, to use that term, but really what it means is to make a 1, can be both numbers or variables, or both. All right, so if we look at this next example, 4x plus 12 over 8. Okay, there's nothing we can do with this fraction right now in the form that it is in, because the numerator is a 2-termed factor, 4x plus 12, and the denominator is a 1-term factor. We can't cancel anything out there. But what we can do is we can factor out a GCF in the numerator, which is 4, and then see what's left in the parentheses, which would be x plus 3 if we factor out the GCF there, and then the 8 stays in the denominator. Well, now, because the 4 here and the x plus 3 are separate factors, we can look at them individually and see if we can simplify with our 8 in the denominator. So we see that the 4 and the 8 can be simplified, okay, and we know 4 is 1 times 4, and we know that 8 is 2 times 4. And most of you won't need to show this kind of work, but I just wanted to show you what I'm doing here. So the 4s, and the 4 in the numerator with the 4 in the denominator will create a 1 or cancel out. What that means is that there is a 2 remaining in the denominator. So our final answer for this example is x plus 3 in the numerator and 2 in the denominator. Now the one on the right, 2x to the third plus 6x squared all over 3x. Again, the numerator is a binomial factor right now. It is all stuck together. The plus sign means all this is together, and then the 3x is in the denominator. That means we can't do any sort of canceling at this point. But again, if we factor out the GCF of the numerator, which is a 2 and x squared, and we've been practicing factoring out GCFs, what we're left with in the numerator is x plus 3. And in the denominator, we have 3x. Now if you look at the factors individually, we have a factor of 2 here and a factor of 3. Those cannot be simplified. 2 over 3 does not have a simplified form. Then we have an x squared, which remember is x times x, if you want to think about it in that way. And in the denominator, we have an x. That means we can cancel or make a 1 with one of these x's. And then the x plus 3 in the parentheses cannot be separated at all, which means you cannot cancel this 3 with this 3 or make a 1. We cannot do that because x plus 3 is a factor stuck together. It's a binomial factor. So again, we are done with this problem, and our final answer will be 2x times x plus 3 over 3. All right, in the next example, what we have here is we have a binomial factor times a binomial factor in the numerator and in the denominator. So if we can simplify an entire factor, we are able to, again, quote unquote, cancel it out or make a 1. So since I have an x plus 3 in the numerator and an x plus 3 in the denominator, I can divide those, which means I have 1 over 1. And our final answer for this example is x minus 2 over x plus 1. Now it's really important to think about this. I took those parentheses out of my answer. I didn't put them in. Could I put them in? Absolutely. But notice if you do not put them in, it does not mean that you can cancel these x's right here. Okay? It is actually very common for people to go, oh, now I'll cancel these x's and I have negative 2 over 1. You cannot cancel these x's because this x is part of a binomial factor x minus 2, and this x is a part of a factor x plus 1. This is the final answer. There's nothing else we can do to simplify this problem. So how about this fourth one? X plus 6 in the numerator and x squared plus 11x plus 30 in the denominator. Again, this is a binomial factor. It can only be canceled out with a binomial factor in the denominator. Right now we have a trinomial factor. But what can we do with a quadratic binomial factor? Well, we can factor it, which is, again, what we've been practicing in previous lessons. We can factor this. We know 30, well, let's point out this. A is 1, so this is our one-step quick method. We have 30, which is 1 times 30, 2 times 15, 3 times 10, 5 times 6. The 5 and the 6 add up to 11, so they're the factors we need. So we have x plus 5, and we have x plus 6. This has now turned into two binomial factors. And now what we see is that this binomial factor of x plus 6 cancels with this binomial factor of x plus 6. Again, our final answer then, be careful with this one, is 1 over x plus 5. Again, remember when I've said the word cancel before? I don't love that word because you think that all this right here is gone then. But what it really is we're dividing x plus 6 over x plus 6, which means we get 1 over 1. So there still is this 1 right here in the numerator. So our final answer is 1 over x plus 5. Okay, so let's look at a couple more examples together, and then I'm going to ask you to try some on your own. First of all, x squared minus 4 over x squared plus 2x minus 8. Again, there's nothing we can do any kind of canceling or dividing right now because this is a binomial factor and this is a trinomial factor. Very important that you don't think you can cancel this x squared with this x squared. We cannot do that. What we need to do is we need to factor the numerator and factor the denominator. Well, the numerator is a difference of squares. It is a difference of squares because it's a subtraction and a perfect square on the left and the right. So we're going to go ahead and put x here and here for x times x is x squared, and a 2 here and here for 2 times 2 is 4. And remember, one has to be a positive and one has to be a negative in the middle. In the denominator, we can again factor in our quick method because this is a 1 out in front of x squared. We have negative 8, which is 1 times 8, but one of them needs to be negative, or 2 times 4, and one of them needs to be negative. These two factors add up to our middle term of positive 2 right here. So we have our factors x minus 2 and x plus 4. At this point, we can cancel any binomial factors that match in the numerator and in the denominator. We have an x minus 2 and an x minus 2, which makes a 1 over 1. Our final answer, therefore, is x plus 2 over x plus 4. Again, we cannot do any further canceling because they're both binomial factors. If it helps you think about them as stuck together, yes, you could just include those parentheses around them as they are in the work that we showed. All right, why don't you pause the video and try this one on your own and then check to see that you have the correct answer when you're finished. Okay, the answer you should have arrived at is x minus 5 over x plus 1. Okay, now this example gives us the opportunity to look at what the work might look like when we have to use magic number to factor. Okay, and I'm going to start this off. I'm going to have you finish it, and I'm going to try to get to this problem as well before my time limit has expired on this video. All right, so here is what I recommend, because this is a little bit strange. Okay, in order to factor this, we use magic number, which we would write negative 18x squared when we multiply the a and the c term. We come up with our factors of 18, which is 1 times 18. One of them needs to be negative, and we have our x's. 2 times 9, and one of them needs to be negative. 3 times 6, one of them needs to be negative. And so we know the factors we need are the 3 and the 6, but in order to get a negative 3 for our middle term, we need to switch the positive and negative term. So this is what we're going to use. Now what I'm going to recommend is that you work vertically for the numerator to show your work, and you work vertically up, I should say, and vertically down for the denominator. So here's what I mean. We're going to do our magic number steps in the numerator going up. So I have the 2x squared and I have the minus 9. I'm going to put plus 3x and minus 6x in from right here. Put those right here. Then we put our vertical line in. Then we factor out our GCF. Remembering to factor out the negative here on this side. Our parentheses match, so we will write our parentheses. And we have it factored. What I'm going to do is show that I've taken this trinomial and changed it to this, and I changed this line here to this line, and then I changed that line to my 2 factors finally. So this is factored into this, and I don't need any of these rows anymore. Now, we need to do the same thing down here. I'm going to pause the video and have you go ahead and run through that one on your own, and then we'll see what happens after we factor to the denominator. Okay, so you should have arrived at 2x plus 3, x plus 3. So this line, this trinomial went to this, and then we end up with our factors right here. Now notice we're looking for factors that are common in the numerator and the denominator, and we do have a 2x plus 3 in both. So if I divided 2x plus 3 by 2x plus 3, I'd get 1 over 1, or just 1. Our remaining factors, I should say, are x minus 3 in the numerator and x plus 3 in the denominator, and that is our final answer. Again, you cannot cancel out these x's or these 3's. They are binomial factors, and we are finished. Now, real quick on the right-hand side here, I want to remind you that this numerator is a difference of 2 perfect squares. We can factor that into x. Let's do this. X times x is x squared, and y times y is y squared, and one needs to be a positive and one needs to be a negative. So that is factored. And in the denominator, x minus y squared, well, anytime you square something, it means multiply by itself. So x minus y squared is x minus y times x minus y. At this time, we can look for common factors. We have an x minus y in the numerator and an x minus y in the denominator, which makes 1 over 1. Notice we cannot cancel this one out with both of these. This one remains. Our final answer for this one is x plus y over x minus y.